NASA's Webb telescope just zoomed into what scientists once called the cosmic tornado. And what it found? It's blowing minds across the galaxy. Buckle up, because this isn't just pretty space dust, it's a real-time peek into how stars are born. A mystery first spotted in 2006 has finally been solved. A fuzzy blur thought to be part of a stellar explosion? Yeah, that turned out to be an entirely different galaxy, just chillin' in the background. Welcome to one of the wildest space reveals of the year. And that blur? It's a full-on spiral galaxy, photobombing the scene from millions of light-years away. It's like a cosmic glitch. A galaxy from deep space just happens to be perfectly aligned behind this violent stellar event. This chance overlap gave us an amazing 2-for-1 view. Webb revealed the background galaxy's distinct spiral arms, glowing clumps of newborn stars and a bluish central bulge full of older stars. Even cooler? You can see structures in its dusty arms that show star-forming bubbles, the kind of detail we only dreamed of before. This galactic gatecrasher isn't part of the Herbig-Haro jet, but its position offers astronomers a valuable bonus view. It's like spotting a city skyline behind a forest fire, both fascinating, both telling their own stories. The alignment is temporary too. In the distant future, the expanding gas from the jet will block our view of the galaxy completely. For now, it's a cosmic coincidence that gives scientists rare data from two very different corners of the universe. But not everything is solved. Take a closer look at this unusual arc-shaped outcrop at the top of the jet. It doesn't line up with the rest of the structure, and it's throwing scientists for a loop. Some think it might be another outflow, maybe from a second baby star nearby that hasn't been identified yet. Others believe it could be part of the original jet that's breaking apart or being redirected. Protostellar jets aren't smooth. They pulse, bend, and interact with everything in their way. One theory? The jet is precessing like a wobbly spinning top, changing direction slightly over time. That could explain why the arcs point in different directions. This kind of instability could also mean the jet collided with something in space, like a dense cloud of gas, and got deflected. It's like a fire hose spraying into a wall. It doesn't go straight anymore. To figure it out, astronomers need more data, more modeling, and more time. And that's the beauty of space science. It's as much about new questions as it is about answers. At the heart of this entire scene is one powerful baby star, CED 110 IRS-4. This Class 1 protostar, still wrapped in its cocoon of dust and gas, is blasting out matter at breakneck speeds, up to 300 kilometers per second. It's like a stellar pressure valve, venting energy as it pulls in more mass from its surrounding disk. Webb's instruments, especially NIRCam and MIRI, picked up glowing hydrogen and carbon monoxide molecules racing away from this object. These traces lead right back to the source like glowing breadcrumbs. And here's where it gets fascinating. These jets aren't just pretty. They play a critical role in shaping the environment around them. They carve out cavities in the dense molecular cloud, slow star growth by blowing away excess gas, and even trigger new stars by compressing nearby material. This is cosmic feedback in action, creation through destruction. Studying how protostars like CED 110 IRS-4 behave helps us understand how stars like our Sun formed billions of years ago. Let's talk about why the James Webb Space Telescope is a game-changer. Before Webb, telescopes like Spitzer gave us valuable clues, but they were blurry, like looking through frosted glass. Webb? It's like someone wiped the window clean. Thanks to its massive 6.5-meter mirror and powerful infrared instruments, it can cut through space dust and show us what's really going on in star-forming regions. It captures light from the coldest, darkest corners of space, the exact places where new stars are born. And unlike Hubble, which mostly sees invisible and ultraviolet light, Webb specializes in infrared, making it perfect for peeking into dusty stellar nurseries. The clarity of Webb's images lets scientists measure structures, track jet motion, identify shock waves, and even estimate temperatures and chemical compositions. For astronomers, this isn't just pretty imagery, it's hard data. It's rewriting our understanding of everything from protostars to distant galaxies, all with incredible precision. You might be wondering, why does this matter? Why care about a cosmic tornado light years away? Well, it's personal. The Herbig-Haro 49/50 outflow is happening inside the Chameleon 1 molecular cloud, one of the closest active star-forming regions to Earth. It's a cloud that's giving birth to stars just like ours. In fact, scientists believe our sun may have formed in a similar cloud environment, surrounded by swirling gas, collapsing gravity, and violent jets. So when we study HH 49/50, we're actually looking into our own past. This isn't just trivia, it's a cosmic mirror. Every detail we learn about how stars form helps us better understand the origins of our solar system, our planet, and maybe even life itself. It also prepares us for studying other worlds beyond our own, exoplanets that orbit stars going through the same processes. Starbirth isn't just a science story, it's our story. Now here's where things get mind-bending. As incredible as the cosmic tornado is, it's not the only thing Webb saw. In the background of the HH 49/50 image, Webb detected countless distant galaxies, many of them never seen before. These are ancient objects so far away their light has been traveling for billions of years. Some of them existed when the universe was just a few % of its current age. Webb's infrared capabilities let it see red-shifted light from these early galaxies, giving us direct insight into the conditions of the young universe. Every tiny dot in the image could represent millions or even billions of stars. That's not just beautiful, it's profound. These observations help scientists understand galaxy evolution, dark matter distribution, and even the rate of cosmic expansion. So while we're focused on one jet from one young star, we're also getting a look at the universe's deep history, all in one snapshot. This entire discovery is built on a cosmic coincidence, a perfect alignment between the Herbig-Haro outflow and a distant spiral galaxy. It's like two actors wandering into the same frame by accident, but the result? Cinematic gold. This alignment allows scientists to study both a nearby stellar birth and a faraway galactic metropolis in one image. That doesn't just make for great visuals, it provides layered data. Researchers can analyze the outflow dynamics in the foreground while examining star formation patterns in the background. It's rare for such diverse objects to line up so precisely, and even rarer to have a telescope powerful enough to dissect both. What we're seeing isn't just pretty, it's productive. This kind of alignment gives us data from different cosmic epochs in a single field of view. It's a gift from the universe, and a gentle reminder of how vast and interconnected everything truly is. The James Webb Space Telescope isn't just a NASA project, it's a human project. Thousands of people across 29 countries worked for over 2 decades to make it a reality. Engineers, astronomers, mathematicians, and technicians from NASA, the European Space Agency, and the Canadian Space Agency all contributed to this masterpiece of technology. The telescope itself launched from French Guiana on a European Ariane 5 rocket, symbolizing a truly international partnership. Its success isn't just about science, it's about collaboration. It shows what humanity can accomplish when we dream big and work together. Every discovery Webb makes is built on the efforts of people around the world, and every new image it beams back isn't just for scientists, it's for all of us. It reminds us that space isn't a distant, unreachable place, it's a shared frontier that we're exploring, together. Since it started operations, the James Webb Space Telescope has redefined what's possible in astronomy. It's given us the most detailed look yet at the atmospheres of exoplanets, peered into galaxies formed just after the Big Bang, and mapped entire regions of starbirth in stunning detail. With every image, we're learning something new, sometimes things we didn't even think to ask. Webb is helping scientists build better models of planetary formation, detect the building blocks of life in space, and refine our understanding of cosmic time. It's not just replacing Hubble, it's expanding the universe of what we know. Its discoveries are fueling papers, inspiring new missions, and sparking imaginations across the globe. Whether it's a faraway gas giant or a glowing arc of newborn stars, Webb is turning the invisible into the unforgettable. A swirling jet of gas, a hidden galaxy, a baby star carving chaos into space. and a telescope that's only just begun its journey. The cosmic tornado is one story, but there are thousands more waiting to be told. With Webb, we'll keep exploring, keep discovering, and keep unlocking the secrets of the universe. So, if you're curious about what's out there, if you want to witness the universe unfold in real time, subscribe, follow, and join us. Because the cosmos is just getting started, and the best is yet to come.